The following training will cover basic rigging. A rigger is a person who specializes in the lifting and moving of extremely large or heavy objects, often with the assistance of a crane, derrick, or chain hoist. Using cranes, riggers and operators lift and transport large and heavy loads, such as equipment or construction materials. They must be able to do so without damaging the load they're moving, property, or personnel. Crane riggers operate under strict quality, safety, environmental, and health regulations and policies. The crane rigger has many responsibilities and plays an integral part in the safety of a job site where cranes are in operation. A crane rigger's responsibilities are to know how to fasten loads in order to meet company and federal rules, regulations, policies, and procedures. You must also know how to use appropriate cables, pulleys, winches, blocks and shivs, wires, straps, and chains. Crane riggers must also inspect equipment prior to use. They may need to oversee or direct crane operators. Crane riggers may need to complete paperwork at the end of a lift, documenting work completed and any problems encountered. They are also responsible for dismantling, cleaning, and storing equipment after use. Education and experience are key to being a safe and efficient rigger. You'll need to complete training to learn how to work as a crane rigger. Cooling Towers LLC also requires our crane riggers to have specialized training and be familiar with the Occupational Safety and Health Administration or OSHA guidelines. Skills inherent in rigging are knowing how to properly and safely use rigging equipment and how cranes operate. Riggers must have impeccable communication skills, be able to work well with others, and have strong mechanical aptitude ability. Having basic math skills and good judgment can help you succeed, as can knowing how to identify and solve problems. This crane rigging training has been developed for those working around the rigging of loads for crane operation and covers the knowledge needed by a worker to safely and properly perform the many tasks required of a rigger. This training only covers the basics of rigging and does not certify you as a rigger. Before making a lift, you will need to ensure all of the following items have been addressed. Ensure the load's weight and center of gravity have been determined. Ensure that there isn't anything inside or outside the load that could shift during the lift. Determine if the load needs protection against damage from the rigging. Ensure all anchor bolts, hold downs, or fasteners have been removed. Ensure that there is no potential for binding. Are load cells required to verify the load is free? Are the attachment points designed to take the load weight? Is the load structurally capable of being lifted without bending or twisting? Determine the additional tension based on the sling angle. Ensure all rigging has adequate capacity for the additional tension. Are shackles correctly sized for the sling eyes? Ensure that the roles, responsibilities, and qualifications for personnel have been defined. Ensure that a pre-lift meeting has been held with all personnel. Ensure that the location for landing the load has been selected and prepared. Ensure that blocking and cribbing is available to set the load on. Ensure a travel path has been determined and cordoned off. Ensure that other personnel in the area have been notified of the lift. Ensure that the lift is within the crane's rated capacity. Have boom deflections been considered? Have any potential crane boom obstacles been identified? What are limits on wind speed for making this lift? Have the ground bearing support conditions been met? Are there power lines in the area? Clearance and spotters established? Is the counterweight swing area of the crane barricaded? Each day before being used, the slings, all fasteners and attachments shall be inspected for damage or defects by a competent person. Additionally, inspections shall be performed during slings use where the service conditions warrant. Damaged or defective slings shall be immediately removed from services. Whenever any sling is used, the following practice shall be observed. Slings that are damaged or defective shall not be used. Slings shall not be shortened by knots or bolts or other makeshift devices. Sling legs shall not be kinked. Slings shall not be loaded in excess of their rated capacity. Slings used in a basket hitch shall have the loads balanced to prevent slippage. Slings shall be securely attached to their loads. Slings shall be padded or protected from sharp objects of their loads. Suspended loads shall be kept clear of all obstacles. All employees shall be kept clear of loads about to be lifted and of suspended loads. Hands or fingers shall not be placed between the sling and its load while the sling is being tightened around the load. Shock loading is prohibited. A sling shall not be pulled from under a load when the load is resting on the sling. There are 2 basic knots for use with tagline ropes. The first knot is a bowline knot. A bowline is a very secure knot which won't slip regardless of the load applied. The second knot is the clove hitch. This is a popular knot for securing to posts, bars, and other round objects. Be sure to never tie the knot inside of a sling. In this slide is 2 working load limit charts for steel chains. One chart is for grade 80 alloy and one chart is for grade 100 alloy. The grade 80 chart represents the steel chain in a 3 or 4 leg bridle sling or a double basket sling at 60, 45, and 30 degrees. The grade 100 chart represents a vertical or a choke setup or a 2-legged or basket at 60, 45, and 30 degrees. The maximum temp is 500 degrees for a steel chain. Maximum abrasion is 15%. On a steel chain, the max stretch is 10%. Additionally, on this slide is a chart that will assist you in making wire rope slings. The chart includes rope diameter, number of clips, turn back, spacing, and torque in foot-pounds. Typically, we will use a 3/8 inch wire rope diameter. When making the wire rope sling, always ensure that you put the saddle on the live end with the U-bolt on the dead end. Don't let the U-bolt cut into the live side. To determine the amount of tension on a sling used at angles other than 90 degrees, use this table to obtain the load angle factor and follow this formula. The formula that will be used is weight divided by number of legs times the load angle factor. For example, if the load weighs 4,000 pounds and 2 slings are used at a 40-degree angle each, you will divide 4,000 by 2 times 1.555, and that will give you 3,110. Therefore, each leg will have 3,110 pounds of tension. Note that it is recommended that you consider that only 2 legs will carry the load, even when using 3 or 4 legs, since it is difficult to assure that all the legs will carry an equal share of the load. To determine the pulling forces to move equipment across different surfaces, you will use the formulas below in this diagram. When using shackles, you will never set the bridle on the pin side of the shackle. Avoid side-loading shackles. The shackle size should be the same diameter or larger than the wire rope size used. Additionally, shackles must be large enough to avoid pinching the synthetic web slings. There are 3 types of eye bolts: universal or swivel eye bolts, shouldered eye bolts, and non-shouldered eye bolts. As with all lifting hardware, eye bolts should be inspected before use. Eye bolts should always be loaded in the plane of the eye. Only shouldered eye bolts can be side-loaded. Spacers or washers shall not be used between the bushing flange and the mounting surface of a universal or swivel eye bolt. Eye bolts and hoist rings should be threaded into the surface a minimum of 1.5 times the thread diameter. Flat washers may be used under the shoulders of shouldered eye bolts to position the plane of the eye. When using a hook, a 90-degree maximum angle for the hook should not be exceeded. Instead, you will use a shackle when lower horizontal angles are encountered. A hook latch, if required, must be operational, otherwise it shall be removed from service. Never tip load a hook. The width of the hook should not be wider than 1/2 the length of the eye. Duplex hooks should be loaded equally on both sides. When inspecting a hook, you will check for distortion or twist, as well as check the throat opening to ensure that it is within 5% of the manufactured throat opening. A hook is not allowed any distortion or twist. There are 3 types of inspections. An initial inspection is before any new sling is placed into service. It shall be inspected by a designated person. A frequent inspection is an inspection that shall be performed by the user or designated person each day or shift the sling is used. A periodic inspection is a complete inspection for damage to the sling that shall be performed periodically by a designated person. Record keeping and documentation may be required for inspections. Slings shall be immediately removed from service if any of the following conditions are present: synthetic web slings, acid or caustic burns, melting or charring of any part of the sling surface, snags, punctures, tears, or cuts, broken or worn stitches or distortion of fittings, missing or illegible identification tag. Wire rope slings, 10 randomly distributed broken wires in 1 rope lay, or 5 broken wires in 1 strand in 1 rope lay. Wear or scraping of 1/3 the original diameter of outside individual wires, kinking, crushing, bird caging, or any other damage resulting in distortion of the wire rope structure, evidence of heat damage, missing or illegible identification tag. Round slings, acetic or caustic burns, heat damage, melting, holes, tears, cuts, or snags that expose the core yarns, broken or damaged core yarns, knots in the sling, discoloration, brittle or stiff areas, missing or illegible identification tag. Alloyed chain slings, cracks or breaks, wears, nicks, or gouges, stretched chain links, bent, twisted, or deformed links, evidence of heat damage, weld splatter, pitting or corrosion, lack of ability to hinge freely, excessive wear on any point on a link, other conditions that cause doubt as to the continued use of the sling, missing or illegible identification tags. This slide covers personal lifting equipment. If you want to use cranes to lift people, it is critical that you adhere to a strict set of requirements. Cranes are not designated to be personnel lifts. In fact, most crane manufacturers specifically state that their machines are for material handling. But it has been recognized that cranes can be used to lift people. The only real issue is how the people involved in the lifting operation deal with the safety issues to ensure that the crane and operation will not injure or kill anyone. The following is minimum requirements for personal lifting equipment. Must be designed by an engineer or competent person. The welder must be certified by the American Welding Society. The latest inspection report must be kept in the waterproof compartment. Must have a minimum capacity of 300 pounds. Have a maximum wire mesh size of 1/2 inch. Have an initial or repaired basket test weight of 150% of the intended load, with a normal operation basket test weight of 125% of the intended load. Minimum test time for trial run is 5 minutes. There are 3 required crane attachments: boom length, boom angle, and an anti-tube lock device. Bridle connections are required to be made with a master link or a safety shackle. Bridle slings can have never been used in regular lifting service. The hook must have a lockable latch. The required reduction of capacity is 50% reduction. Access doors are required to swing inward and latch. Handholds are required around the entire perimeter. Inspections are required annually, monthly, and periodically. Lifeline anchorage requirement is 5,000 pounds with a body harness tensile requirement of 4,000 pounds. The crane is required to be within 1% of level. The only person who can have a body part outside of the basket is the signal person. When cranes are set up close to excavations or trenches, there may be an increased risk of the sides of the excavation or trench wall collapsing, causing the crane to overturn. This risk increases with softer ground and the presence of groundwater. The risk of collapse is greater for vertical cuts in the excavation wall compared to walls that have been sloped back at an angle. The following have a direct effect on the ability of the ground to support loads: trenches, embankments, excavations, ditches. General rule: outriggers should be positioned a minimum of 2 times the height of any trench, excavation, or ditches. The operator must also be made aware of any underground utilities that can affect support on the job site, such as basins, vaults, cellars, buried tanks. General rule: outriggers should be positioned a minimum of 1.5 times the height of any cellar, vault, or basins. Before assembly or disassembly of a crane, the employer must determine if it could come within 20 feet of a power line. If so, the employer must either confirm with the power company that the line is de-energized and visibly grounded at the work site, or make sure no part gets within 20 feet of the power line, or follow the requirements of this table, which has minimum distances based on voltage. If the line is de-energized, which is usually the case, the employer is required to conduct a meeting with the assembly and disassembly crew to review measures to prevent encroachment. They must use only non-conductive tag lines, and they must use a dedicated spotter, an elevated warning line or barrier in view of the operator, or an alarm or automatic control system. Cranes cannot be assembled or disassembled below an energized power line or within the minimum distance referenced in the table of a power line. And if the table is used, the owner or utility must provide the voltage to the employer within 2 days of a request. Power lines must be assumed to be energized until they are confirmed to be de-energized and visibly grounded. Warnings about electrocution hazards must be posted in the view of the operator in the cab and outside the cab. The work zone around the equipment must be marked 360 degrees around the equipment to prevent encroachment within 20 feet of a power line. If the line is not de-energized, a meeting must also be held with the crew before operations begin to review the location of the lines and procedures to prevent encroachment. Operators and crew members must be trained on the procedures to follow in the event of a contact. That power lines must be presumed to be energized until confirmed and visibly grounded. That power lines are presumed uninsulated until otherwise confirmed by the owner or a qualified person, on the limits of insulating links and other devices, and on proper grounding procedures and their limitations. Spotters must also get training as applicable to their work and responsibilities. Hand signals provide a simple solution for the communication issues faced by crane operators. Although radios can be used to relay messages across the site, there are some situations when an operator will need extra assistance. Construction sites are loud. They produce a high level of noise from activities such as digging, pilling, and drilling. Therefore, it can be difficult to convey instructions in an accurate and time-efficient way. There are also times when an operator's directional visibility is obstructed or the visibility of a load area is partially blocked. Conducting a lift with these types of conditions can put the operator and the workers around them in serious risk of injury. Although it is recommended to use hand signals during all lifts, it is these times when a signal person will be called upon. Easy to understand, hand signals help the operator avoid any potential hazards, completing actions in a safe and timely manner. The following are hand signal descriptions. Move slowly is signaled by using one hand to give any motion signal and place the other hand motionless in front of the hand giving the motion signal. The hoist signal is given with forearm vertical, forefinger pointed up, moving hand in small horizontal circles. The lower signal is given with arm extended downward, forefinger pointing down, moving hand in a small horizontal circle. To give the extended boom signal with two hands, both fists are in front of the body with thumbs pointing outward. To give the extend boom with one hand, fists will be in front of the body with the thumb pointing towards the chest. To give the retract boom signal with two hands, both fists will be in front of the body with thumbs pointing towards each other. To give the retract boom signal with one hand, your fist will be in front of the body with thumb pointing away from the chest. To swing the boom, point with the finger in the direction of the swing of the boom. To signal to dog everything, clasp hands in front of the body. To give the stop signal, you will extend one arm with the palm down and wave it. To signal an emergency stop, both arms will be extended, palms down, and waved. On a side note, emergency stop is the only signal that a crane operator must listen to regardless of who gives the signal. To signal the crane operator to use the main hoist, tap first on your head, then use regular signals. To signal the crane operator to use the whip line or auxiliary hoist, tap elbow with one hand, then use regular signals. To signal the crane operator to raise the boom, your arm will be extended, fingers closed, with the thumb pointing upward. To signal the crane operator to raise the boom and lower the load, your arm will be extended, your fingers will be closing and opening, with the thumb pointed upward. To signal to lower the boom, your arm will be extended, fingers closed, with a thumb pointing downward. To signal the operator to lower the boom and raise the load, you will extend your arm, with the fingers closing and opening, with the thumb pointing upward. As the eyes and the ears of a dedicated area or crane, a signal person carries many responsibilities. Before a person can direct the operations of a crane, they must first undergo formal training and complete a qualification in crane signaling. In training, a person will not only develop an understanding of hand signals, but they will also be required to become familiar with different types of cranes, how each crane functions, and any hand signal specific to the equipment. The trainee signal person is required to grasp an understanding of a large library of signals without any memory prompts and showing competence in recalling these during an examination. The signal person is also responsible for preventing injury and accidents to the best of their ability. This is done by following strict procedures during crane operations, for instance, standing in clear view of the crane operator, ensuring the operating area is clear of people and hazardous objects, and performing one signal at a time to avoid confusion. The signal person must have a basic understanding of crane operations, limitations, crane dynamics, and boom deflection. Have demonstrated through a written and practical test understanding of the methods for crane hand signals. Additionally, they will need documentation from a qualified evaluator or a third party that they meet the requirements. Voice signals may be required in some instances due to obscured views. Voice signals must contain the following three elements, given in the following order: function and direction, distance and or speed, function with the stop command. Voice signal examples are swing right, 30 feet, 20 feet, 10 feet, swing stop. An additional example is hoist down, slow, 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 Hoist stop. When using voice signals, all directions are from the crane operator's perspective. Before the lift, the operator, signal person, and lift director must meet and agree on the voice signals to be used. Safety is the number one concern for a crane operator. A person performing the hand signals stands at a vantage point which allows them to view the load area from a perspective that is not visible to the crane operator. From this point, the signal person can confirm whether a maneuver is safe to perform and halt all activities if they observe a potential risk. Cranes have incredible capabilities. However, if operated incorrectly, they can pose significant danger to construction workers on the site and, in some cases, the public. Hand signals have been established as a reliable, low-tech, and universal way to improve safety during operations and avoid accidents.